Before we do some harder problems, I'd suggest that you try this one on your own. So let me explain the problem, then you should pause the video and try to work it out. Then you can come back and I'll work it for you. Here I want us to find the double integral over r of x dA, where r is the region in the first quadrant between circles of radius 1 and radius 3, and bounded on the sides by the line y equals x and the y-axis, which is the same as x equals 0. So if you think you got a handle on it, pause the video, then come back and see if you got it right. Two parts that are quite easy are the differential and the integrand. Remember, in polar coordinates, dA is always going to be replaced by r dr d theta, and x is r cosine theta. So we'll have the double integral of r squared cosine theta dr d theta. Now, another thing that's fairly easy is that these circles have radius 1 and 3. So I'm going to be going from r equals 1 to r equals 3. The theta might be a little bit trickier. You might can guess at it, but let me show you a general way that you can figure it out. This line is the same as y equals x. Plugging in y equals r sine theta and x equals r cosine theta, that's the same as r sine theta equals r cosine theta. We can divide both sides by r and divide both sides by cosine theta, which gives us that tangent of theta is 1. And of course that happens when theta is pi over 4. So this edge is the same as theta equals pi over 4. And the vertical part, x equals 0, well, we can see just visually that that's the same as theta equals pi over 2, or we can substitute in r cosine of theta equals 0, so cosine theta equals 0, and that indeed happens when theta is pi over 2. So our bounds on theta are from pi over 4 to pi over 2. Now, in the previous problem, we were able to split this up as the product of two integrals. Can we do the same thing here? We can. Notice that all four bounds are constants, and the integrand is the product of a function of r and a function of theta. So we have the integral from pi over 4 to pi over 2 of cosine theta multiplied by the integral from 1 to 3 of r squared dr. Integrating here, the integral of cosine theta is sine theta. That'll be taken from pi over 4 to pi over 2. Antiderivative of r squared is 1/3 r cubed. That'll be taken from 1 to 3. Sine of pi over 2 is 1 minus sine of pi over 4 is square root of 2 over 2 times 1/3. Plugging in these endpoints and subtracting, 3 cubed minus 1 cubed is 27 minus 1. So I get 26/3 multiplied by 1 minus square root of 2 over 2.